So, good afternoon, distinguished ladies and gentlemen. You are welcome back to today's lecture. Uh, as you know, due to electricity problem, we couldn't finish the lecture 2 last week. So we will use today's lecture to conclude that outstanding part. And then tomorrow we will start lecture 3 fully. But before we go to what we have today, if you have any quick comment, concern, or reaction, let me entertain that as quickly as possible. Let's be time conscious. Is there anything from you, Odinaka, Peter Paul? Is there anything divine? Allow, Eneoluwa, Samuel, Taiwo, do you have anything that you want to say? Question, comment?
No, sir.
Go on, Eneoluwa. Did you say no or you say? I didn't hear you, Eneoluwa.
Oh, sir. No question for now, sir.
Excellent. So I take that to represent the position of the entire class. But if there is anyone, you can use the raise hand icon or you unmute and ask your question. So I'm going to share my screen. I'm going to share the entire screen. Yes, Eneoluwa, your hand is raised up. If you have anything, let me know. You can unmute and talk. Eneoluwa, your hand is up. You can unmute. Okay,
Oh, sorry, sir. That was a mistake, sir.
no problem. So I think you can see my screen. You can mute yourself now. You can see my screen, and this is our classroom page. You're already familiar with this, and this is where you have the lecture material. So the lecture 2 that we will be discussing is here. The video for the last lecture is uploaded. The Jamboard that we used is also here. We will also use it, continue with it today. And here is the attendance for that last meeting. Then you have the material for that lecture, which we are going to conclude today. So let's go straight to that lecture. This is the lecture, and a quick rundown of that lecture. You recall that we briefly talk about sampling and what it means, the importance of sampling in statistics, uh, and the need to ensure representativeness in our sample so that our sample is able to reflect the diversity of the population. Uh, every group, every component, every section is given due representation. Then we emphasize on the application of sampling across different fields. Um, then we look at things that you should take note, which at the end of the lecture you should be able to understand and explain very clearly. Uh, you should understand sampling distributions, what the concept means, and the importance of that concept. We tried to do that last week. And then you also need to know the difference between standard error and the standard deviation. This is very important as a major outcome or as a key learning in this lecture. Um, in addition, the properties of sampling distribution of the sample mean is explored. And when we talk about these the properties, we look at the center, the spread, and the shape. We are still going to talk more about those ones today. And then we also need to know the distributions in various conditions. Conditions when the um, the distribution is normal or when the distribution is not normal. So I emphasize the fact that when you have, um, you could have population, you could also have, you could also have, you could have population, you could also have a sample. And I told you the quantity that you measure from the population, they are called uh, the parameters. So you measure the mean, the variance, the standard deviation, and all of that. The corresponding measure from sample, they are called the sample statistics, or generally called statistics. So we mentioned this, and you can calculate the population mean, you can calculate the sample mean. So we look at that. These are population uh, uh, quantities. So we call them parameters. The population mean, the population variance, sigma square, population standard deviation, sigma, which is the square root of the variance. So these are population quantities. The statistic which you have, these are statistics, the sample mean, the sample variance, the sample standard deviation, and if we are talking of proportion, the sample proportion. So these are sample statistics. And so we can talk about the sampling distribution of a statistic. And that statistic could be sample mean, could be sample variance, could be sample standard deviation, could be sample proportion. So sampling distribution, we will say sampling distribution of sample mean, sampling distribution of sample variance, and so on and so forth. We only talk of sampling distribution with respect to statistics. We don't talk of sampling distribution of parameter, because parameter itself is actually the truth that we are looking for. But when we take sample and we compute the statistic from the sample, it will always deviate from the population. But our interest is to see if we take all possible samples from that population, then how does this statistic, the computed statistic, how does it behave? Is somebody raising up hand? No. So that has been the concern, and we discussed that. So I gave you a very simple example of what distribution means. So distribution is simply, looking at the frequency of occurrence of a particular observation. So you can have frequency distribution table, cumulative frequency distribution table, and so on. So the idea of sampling distribution of a statistics is actually to look at that statistics and see the distribution of that statistics. Maybe sample mean, sample variance, sample standard deviation. So we took this example last week. We have a population comprising of three observations, 18, 22, 17. And we took samples of size 2. And in that sample, the samples were drawn, of course, without replacement. So we came up with three samples. Sample 1, 18 and 22. Sample 2, 18 and 17. Sample 3, 22 and 17, because they were all drawn from here. But each each uh, each draw we took uh, only two observations, so we call the sample of size 2. And then the statistic of interest is the sample mean. So which means this will have its own mean, this will have its own mean. So sample mean 1, sample mean 2, and then sample mean 3. So that sample mean is what to have here. So sample mean 1, sample mean 2, sample mean 3. And that uh, means that when you take different samples, you are likely to get different uh, values for the sample mean. But you will see that that sample mean is not the same as the population mean. So this is this population mean, but as you take different sample, the mean of that sample will differ. It could be the same, but most cases it will not be the same. So it will vary. It will move around the. So this is the truth. This is the truth, if you would like that. But when you take sample, you are only estimating the truth. So that is what is sampling. So uh, we said the sampling could be with replacement, and if it's with replacement, then the formula is the is n raised to power k. N is the size of the population, k is the sample size you want to draw. If it is without replacement, then you use the combinatory formula. So if you have three uh, observations in your population and you are only drawing 2, then you have 3 combination 2. So we demonstrated the case with replacement, and we were able to obtain 9 different samples of size 2 when you have just 3 observations from the population. So which means each sample will have its own mean, and so on and so forth. I think that was the extent we could go last class. Then, so we we discussed all of this, and then we got here, and I was trying to show this simple simulation that we did. So in this simulation, we simply have in our population 0, 2, 4, 6. And uh, in the next line of command, we computed the population mean, which is the average of these 4 observations. 0 plus 2, that's 2 plus 4, that is 6 plus 6, that is 12. So 12 to get the mean, and we have sum of 4, so it is 12 divided by 4. So this is the population mean. And we can also get the population standard deviation. This is what is obtained here, and that is the population standard deviation. So in that particular example, where you have the population data to be 0, 2, 4, 6. So we have the population mean to be mu, and that is 3. Then the population standard deviation, which is sigma, we got that to be in our computation, that gives us 2.581. So 2.581. Is somebody raising up hand? No, okay, people are joining, that's okay. So you have the population mean, you have the population standard deviation. But we want all possible samples of size 2 that we can draw from this population. So using the R code, this is combination. So take note, is the function. This is, we use the function comn. So we provide the population and the sample size we want to draw. So this gives us the possible samples: 02, 04, 06, 24, 26, 46. And that means that if we draw a sample of size 2 from a population of 4, then we will get 6 different samples. And these are the samples: 02, 04, 06, 24, 26, 46. And therefore, you can also list all possible samples. So you can talk of all possible samples. So you have here, you have here 02, 04, 06, 02, 04, 06. Then you also have 24, 26, 46, 24, 24, 26, and then 46. So which means you can have how many possible samples? 6 possible samples. And then our interest is the sample mean. So which means we are going to have x bar 1, that is the mean for the first sample, 0 plus 2 divided by 2, that is 1. 0, so we are going to have also x bar 2, 0 plus 4 divided by 2, so 4 divided by 2, so and so on and so forth. That's what we obtain here. So these are the sample means. You can also complete this. So the next one will be 0 plus 6 divided by 2, that is x bar 3. This will be 3. And then again, this will be 2 plus 4, 6 divided by 2, that is 3. So which means we are going to have x bar 4 to be equals to 3. And then this will be 2 plus 6 divided, that's 8. So x bar 5 equals to 4. And then we have 4 plus 6 divided by 2, that is 10. So x bar 6 is 10 divided by 2, which is 5. So we have, these are the 6 means that we have. And we can now look at the distribution of these 6 means. If you look at the distribution, so you will see that you will have a table, something like this, which will show the mean x bar, which could be 1, which could be 2, which could be 3, which could be 4, and so on. So 1 appears how many times? 1. 2 appears 1. This is the frequency. 3 appears 2 times. 4 appears once. So you will have a table, and then which will show you the frequency. So these are for sample 1, you have 1, the mean is 1. For sample 2, the mean is 1. Sorry. For sample 3, so this is the frequency table. For sample 3, the mean is 2. For sample 4, the mean is 1. For sample 5, the mean is 1. And this is what is shown in the histogram here. So it's only sample 3 that you have the mean to be 2. The rest you have, for sample 1, the mean is 1. For sample 2, the mean is 1. For sample 4, the mean is 1. So this is the distribution of the sample mean, which we now call the sampling distribution of the sample mean. That takes us to a very important concept again, and this concept is aimed at understanding the concept of standard error of a statistic. So you will notice that here we have talked about this population standard deviation. So the standard deviation is obtained from the population. It's obtained, is a quantity computed from the population. But now we have several means. We have x bar 1 giving you 1, x bar 2 giving you 2, if I'm correct, x bar 3 giving you 3, x bar 4 also giving you 3, x bar 5 giving you 1, x bar 6 giving you 1. This sorry, giving you 4, 5, sorry, giving you 4 and then 5 respectively. So this actually is what we will call the sampling distribution of sample mean. So because it shows this distribution of the various means, how the mean obtained from different samples of a given size, how they behave. That is what the sampling distribution gives. The sample, the, the distribution of the sample mean obtained from all possible samples of a given size. In this case, the size is 2. So this is called sampling distribution. But you can see, uh, we can go further to do a lot of other computations. I can find the mean of all these means. In that case, I can talk about x bar bar, which means I'm finding the mean of means. So I can call this the mean of means. The mean of means. I'm finding the average of the averages. And since I've called this already, this means I've called it the sampling distribution of sample mean. I can also see now that I'm interested in the mean of sampling distribution of sample mean. So, which is the average of all possible samples. Average of the means from all possible samples of a given size. So that will be summation of all the x bar I, and I now will go from 1 to, in this case, the number 6, and then I have to divide by how many of them? By 6. So I will call this the mean of means, or the mean of sampling distribution of means. I can also talk about the variance of all this. I can also talk about the standard deviation of this sampling distribution. So what do I now call that one? When I now find just the way I call it, the mean of means, what do I now call the standard deviation of the sampling distribution of the sample mean? The answer is standard error. So you can now define standard error of a statistics. And the statistic could be mean, could be proportion, could be wherever. So you could define the standard error of a statistic as the standard deviation of the sampling distribution of the statistic. So from here, you can easily see the difference between standard error and standard deviation. So you can see now that you can't talk of standard error without talking of a statistic. So if I replace this statistic by sample mean, then I can define the standard error of sample mean as the standard deviation of the sampling distribution of the sample mean. If I replace this word statistic with any other thing, standard deviation, proportion, then the standard error of that statistic is the standard deviation of the sampling distribution of that statistic. So if it is mean, for instance, if I say this is mean, then it means I'm looking for the standard deviation. Instead of putting just x here, I will now put x bar, because this symbol itself stands for standard deviation. And this is now saying I'm interested in the statistic mean and not just the random variable. So I will say this is the standard. This symbol is given as the standard error of sample mean. But if I write this, then I can't call it standard error. It's simply standard deviation. Simply standard deviation. So you should get it you should get it right. So you can't talk of standard error without you referring to a statistic. That statistic could be the sample mean, could be the sample variance, could be the sample standard deviation, could be the sample proportion. So get that very well. So let's go back. The definitions are now provided in our lecture note. So when we talk about the standard error, it's a measure of the variability or dispersion of a sampling statistics. So it simply represents how much that statistics vary from sample to sample, because when you look at, you can see how the mean is varying, is changing from sample 1 to sample 2, how it's changing from sample to sample. So it means from that population of 0, 2, 4, 6, the least, if I take any sample, the smallest sample I will get, the smallest mean I will get is 1. And the highest mean I will get is 5. So that shows you, So if I now decide to find the average of this, then I'm talking about so in analyzing that those values from x bar 1, x bar 2, x bar 3 to even x bar, in our case, x bar 6, we can see different values. X bar 4, x bar 5. You recall the value in this case was yeah, the value in this case was 1. So we have 1, 2, 2. We have 1, 2, 2, 3, 4, 5. So these are the means. These are the means. And I can find the mean of this. So if I find the mean of this, that will be 1 plus 2 plus 2 plus 3 plus 4 plus 5. Let's do it. So do it, everybody. Tell me the mean of these means. And type your answer in the chat menu. Give me the mean of this mean. 1 plus 2 plus 2 plus 3 plus 4 plus 5. Who has done that? Nobody has done that so far. Nobody has done that. Type your answer in the chat menu. Nobody has done that. Gabriel, what's your question? Type your answer in the chat menu. Gabriel, you are raising up your hand. Are there people in this class? Nobody is responding.
Yes, sir. We are here, sir.
Okay, I can't see. Somebody got 3. Only Shidera has submitted. Praise Taylor 3, 2.83. Okay, so let's do it together. 1 plus 2 is 3. 3 plus 2, that's 5. 5 plus 3, that is 8. 8 plus 4, that is 12. 12 plus 5, that is 17. So the mean is 17 divided by how many observations have you added? You have added 6. So 17 divided by 6. What is that? 17 divided by 6. 17 divided by 6. It's actually
That's
2.8. So this is 2.83. So if you look at it now, only few people got it. Odinaka, you missed it. You didn't do it correctly. Gabriel, you got it. Peter Paul, you missed it. Ineoluwa, you missed it. Bilikis, you missed it. Choosing, you missed it. Praise, you missed it. Chidera, you missed it. Domini, you got it. Olowu, you got it. Maybe you got it from behind. In any case, you tried, so that's good. So this is the mean of the means, because these are means. But we can also find their standard deviation. Their standard deviation. So if we find their standard deviation, we will no longer call it standard deviation, but we will call it the standard deviation of the sampling distribution of the sample means. So the standard deviation will be denoted by sigma x bar. So it will not be appropriate to call it standard deviation any longer, but we will now call it standard error. So that is what we want to emphasize. So the standard error is actually the standard deviation of the of the sampling distribution of the sample mean. So if you compute this standard deviation, which you can easily compute, you know, we have, so we can easily compute. And in our, I think in our computation, yeah, so we didn't. So if we want to do that, we can easily do that in R. So we can, we can say, okay, if we have the means, let me say I have the means here, means to be equals to uh, what are the values? We have one, we have one, we have, sorry, we have one, we have two, we have two, we have two, then we have, I hope I'm correct, I hope I'm correct. Yeah. Oh, I actually got it wrong. These are the means. Nobody corrected me. These are the means. 1, 2, 3, 3, 4, 5. 1, 2, 2, 1, 2, 3, 3. 1, 2, 3, 3, 4, 5. Sorry for that mix up. So there is a little error there. So this should be 18. So, oh wow. So this is actually 18 divided by 6. That is 3. So those who got it earlier, they are actually wrong. So this is 3.0. So we should give credit to those who deserve to be given credit. Who are those that I should give credit to now? Yes, I'm giving you your due. Chidera, you actually got it because you used the correct, yes. Praise, choosing, good of you. I know I misled Akinyemi, so I will take responsibility for those who got 2.83, but I should clap more for Bilikis, Ineoluwa, chosen, praise, Chidera. You are actually more intelligent. That's good of you. But I will still know later whether those I withdraw, they are uh, those I withdraw their praise. They are if they are intelligent. If you are following me, say yes in the chat menu. If you are following me, say yes.
Yes.
Okay, good yes. Okay, that's good. Only yes, yes. So yes. So I don't know those who are intelligent virtually, at least. Uh, so sorry for that uh, mix up. So now I can come back and put this as 1, 2, 3, 3, 4, 5. 1, 2, 3, 3, 4, 5. And I can actually find the mean of this means. So if I find the mean of this means, you will see it will give me 3. The 3 that we obtain. If I now want the standard deviation of this means, is actually going to be, so you know the formula for finding standard deviation, but this is going to be the standard deviation. So which means this gives me 1.414. So this is 1.414. So this is actually the standard error, or another is to call it the standard deviation of the sampling distribution of the sample mean. The standard deviation of the sampling distribution of the sample mean. Don't forget. And that value is this. So this mean, there are three things that are actually of interest when we talk about the properties of this uh, uh, distribution. One, the center. Two, the spread. Three, the shape. The center, the spread, the shape. So the center is looking at the average of all these means. So the average is 3.0, which means the average of this mean, the center is somewhere here. Is here. That's the center. The spread is looking at how each of the mean depart from the center. So it's like you have three here, then you have one, you have two, you have four, you have five. This is the center. How far is this one from the center? How far is this one? So the spread is looking at how the means, how they spread around the center. That's the measure. In fact, that's what the standard error measures. The center, that's what the mean of means, that's what it measures. The shape is what you see in terms of the shape of the histogram. And you can see the shape here, how the shape of the histogram looks like. So is the shape normal or is the shape not normal? You can see the shape is even though the sample is very small, it's still normal. So for you to have a normal shape, you expect the histogram to have something like this, so that the majority are concentrated in the center, which is what you see in that shape. So that's what we are talking about here. So the standard error, we can now compare it with the standard deviation. Standard deviation measures variability within a single sample or a population. So it's just in a single sample when we talk of standard deviation. But when we talk of standard error, we are measuring variability of a sample statistics, the estimate of that statistics. And you will notice now that if you look at the population mean, look at the population itself. We computed the population mean. Sorry. If you look at the population mean, which is 3. So what can you say now, everybody? Look at the population mean. So one thing you notice now, which you must never forget, the population mean was 3. And now that we have computed the mean of means, we have seen that the population mean is actually equals to the mean of means. So that is expected. So which means the population mean is actually equals to the mean of means, or is equals to the mean of the sampling distribution of the sample mean. So that is a key result, that if you have the population, the mean of that sample of the population is going to give you the mean of the means from all possible samples of a given size drawn from that same population. So that is an established, you know, uh, result. But if you now look at, when you look at the population standard deviation is 2.581, and you now look at the standard error, they are not the same. So one major finding or result is that you can always get the standard error. This is the standard error, which from now I can call it SE rather than standard deviation. So this standard error, as you will see in the formula given here, can also be obtained by simply dividing the standard deviation by the square root of the sample size. So in our case, remember the standard deviation we obtained, the standard deviation was 2.581, 2.581, 2.581, and divided by the square root of n. Our square root, our n is 2. 2 is the sample size. 2 is the sample size. Can somebody calculate this and give me the answer? Write your answer in the chat menu. We have 5 minutes to the end of the class, and that's where we will stop. 5 minutes to the end of the class. Who has done that? Who has done that? People are tired. You cannot be tired. Nobody has done it. Is it difficult? You have to compute 2.581 divided by, so I can use R to do the calculation straight away. So I can have 2.581 divided by square root of 2. I hope I'm correct. So, and the answer is 1.825. The answer is 1.825. You can see this is giving me the same thing that I actually, yeah, this is giving, it should actually give us this value, 1 point, yeah. It should, I hope I didn't mix anything. Let me look at what I got as the standard, sorry, 2.581. So 2.581, that was the standard deviation. What was our standard error? So our standard error was 1.414. Please check the calculation. So the standard error we obtain using this formula, the standard error is obtained by simply dividing the population standard deviation by the square root of n. N is the sample size. So the formula is there. So which means you can use this formula straight away if you know the population standard deviation, and you don't need to now draw all possible samples, calculate their means, and then begin to find the standard deviation of all the means. So as we continue in this course, you will now be able to see the importance of this measure that we have, this statistics that we have computed. So very important if we have to construct confidence interval and carry out hypothesis testing. And you will see that when your sample size becomes very large, then the standard error will become very small, because your standard population, standard deviation will be constant. It doesn't change. So that tells us something, that if you want more precise estimates from your sample, then you need to take more from your analysis. You need more sample to get small standard error. So the effect of sample size, one, is that the standard error, decreases as the sample size increases. And you will notice that from this formula, straight away from this. If I increase the sample size, then this standard error will reduce. If I reduce the sample size, this standard error will increase. So there is a kind of this opposite relationship. As one increases, as sample size, as n increases, SE decreases, and vice versa. So this is a good place to stop. The rest is talking about the properties of the sampling distribution, which we have talked about: the center, the spread, the shape, and the distribution, particularly if we are interested in standard deviation. We will still talk about proportion tomorrow, so we don't need to spend time. And then you can see if the original sample is normal, then you expect that the sampling distribution will also be normal. So we will still refer to some of this in our subsequent lectures. I believe you have another lecture. So this is a good place to stop. Thank you very much. If there's any question, feel free to ask, or I can release you now for another class. But if you have if you have a question, you can just wait, ask your question. So let me stop presenting. Let me also stop recording. We meet